All right, y'all, so this begins our review on confidence intervals for means and proportions. We're going to spend 2 whole days reviewing this because it was our lowest unit of the year, and on the benchmark, even though we reviewed heavily, we were still a little bit behind where I'd like us to be. So we're going to do one model problem today in a video, and then one model problem tomorrow in a video, and then we're going to practice in class for 2 full days. All right, so just a reminder, confidence intervals are when it asks us to estimate a range of numbers. And so we're typically given like a type of confidence interval. It says like a confidence level that we're supposed to run. And so we want to use the normal model to do this. So let's look at the formula chart. The formula chart All right, the formula chart gives us this formula right here, and you have to be able to use the test statistics and the standard deviation from the other part of the chart. These are the formulas. Now remember, we're at this point in the year writing the name of the test and not leveraging the formulas so heavily. So let's scroll down. So this problem is talking about trichomes. They're a hair-like outgrowth on the epidermis of a plant that are thought to provide protection against being eaten by herbivores. A certain plant species, the stem trichome density is genetically determined. For plants in this region, a stem trichome density greater than or equal to 12 hairs per centimeter, so I think I'm probably going to need that part, has been proven effective defense against herbivore attack. The dot plot below shows the stem trichome density measured in number of hairs per square centimeter from a random sample of 22 plants in a region where this plant grows in abundance. Sorry. So the first question asks us to know what proportion of plants in this sample have an effective defense against the herbivore attack. So here 12 hairs per centimeter has been proven effective. So that means that this portion of the dot plot represents those. So that's 4 pieces of the data. So we would do 4 divided by 22, and that would be our proportion. Okay. Now the next part says the mean stem trichome density of 22 plants in the sample is 9.455, so that's going to be my X bar. And the standard deviation, which is going to be my standard deviation X bar, is 2.4. Oh, I'm sorry, I don't know what's going on with my screen. 2.483. So we want to construct and interpret a 99% confidence interval for the mean stem trichome density for this plant species in the region. So we have one sample and we're talking about means, so this is going to be a 1 mean t interval. So let's go ahead and draw our box. So what's nice about this is the format is the same as when we were running a significance test. We're just going to change what we're putting in the boxes a little bit. In particular, like the math box and the conclusion box are going to be quite a bit different. Now, the mean that we're interested in here is the mean stem trichome density for this plant in the region. And then we're going to have our simple random sample. We were given a simple random sample. And then here you would want to think, do I have more than 30 pieces of data? So here I have 22 pieces of data. So if I'm checking normality, I'm actually gonna want to go back up to the dot plot. So if we look, this is symmetric enough with no outliers that we're comfortable enough. So we're going to say the graph given is symmetric enough with no outliers. Okay. So once we've defined our parameter of interest and we've checked our conditions, then we're going to want to go ahead and run the run the confidence interval. So here our degrees of freedom is 21. Now I went ahead and typed this into my Inspire, which we're going to go over tomorrow, but my interval is going to be 7.96 to 10.95. And remember, we're measuring this, so it's hairs per centimeter squared. Okay, and the formula here would be x bar plus or minus that margin of error. All right, so our last little bit is to conclude. I'm actually going to erase this part of the line and draw it a little bit different so I have a little bit more room to write. So here we are going to say we are 99% confident that the mean stem trichome density for this plant in the region is between 7.96 and 10.95 hairs per centimeter squared. Okay. And then that's the end. So tomorrow we're going to look at how to use the calculator and practice some of these problems, and then you'll have the video for model problem 2 on tomorrow night. All right, I'll see y'all in class tomorrow.